Time to rock with some applications to real life. A long time ago, you got some formulas converting Celsius to Fahrenheit and Fahrenheit to Celsius. And this is a really good example of how those formulas were derived. So follow along. Applications, the relation between, and by the way, when I say a long time ago, I'm talking science class in like 8th grade, okay? The relation between the Celsius and Fahrenheit temperatures is linear. That means straight line, thinking y equals mx plus b. The graph of this equation contains the points 0, 32. Water freezes at 0 degrees Celsius and 32 degrees Fahrenheit. And it also contains the point 100, 212 because water boils at 100 degrees Celsius and 212 degrees Fahrenheit. Find the linear equation expressing the relationship between Fahrenheit and Celsius. Which one is your x? Okay, so what we're going to do is ask you to write the equation of the line, and I would have your x be Celsius and your y be Fahrenheit, okay? So I'm going to do a little stop and start here and hope all of you have a good sense of direction. Your 2 points are 0, 32 and 100, 212. So you're going to work this just like you worked the other ones that had a pair of points. When we did those 3 on the same line, we had to find the slope, okay? So try those right now, and if you get stuck, then when I go over it using the stop and start technique and get started on it, you should be able at some point to say, oh, I got it from here, I can take it from here. Go ahead. Well, anytime you're going to write the equation of a line, you need the slope and the y-intercept and then fit them into y equals mx plus b. So we know the slope is the change in y over the change in x, which in this case, and it's also y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this case, I'm going to do the second point minus the first, which is 212 minus 32 over 100 minus 0. That gives me 180 over 100, which reduces to 9/5. B, the y-intercept always pairs up with 0. So since when the input is 0 and the output is 32, we know that the y-intercept, or b, is 32, which is nice. It tells me that the Fahrenheit, which is the y value, right? Here's your Fahrenheit, boils at 100 Celsius. So the Celsius, since we wrote 100, 212, the Celsius is x, and the 212 is the y, or the Fahrenheit. So the y, being like Fahrenheit, is Fahrenheit equals 9/5 the Celsius, which is like the x, plus 32. So there is how you derive the formula for converting from Celsius to Fahrenheit. Don't know if you ever knew how to derive that formula. The formula that you have seen since middle school, now you know how to do so. But that is not, I repeat, not the only way to write an equation from a line. That's the slope-intercept form. There's also a point-slope form. The point-slope form equation of a non-vertical line is that the slope passes through the point x1, y1. Now, this is the point where, to me, this seems like something disconnected when you look at this formula. It looks like something disconnected from what you're learning, and it's like, oh man, I got to learn something new, or I'm not comfortable with this. But the truth of the matter is that this is just the slope formula and cross multiply. So that's all it is the slope formula, and you cross multiply. So let me show you how to get this, okay? Here's your slope formula. Slope is m equals the change in y minus y1. I didn't put sub 2's on it because I wanted to look like this formula, but it's the same thing, over x minus x1. And if I cross multiply, look, put the m over 1, I get 1 times y minus y1, which is just y minus y1, and then the x minus x1 gets multiplied by the x, and you put it in parentheses. So it's the same exact formula, nothing changes. All right, so here it says, write the equation of the line passing through the point 2, -4, with a slope of -3, point slope and slope y-intercept, or slope-intercept forms. Point slope and slope intercept. So let's do slope intercept first because we're experienced with that. Do stop and start with y equals mx plus b. Come up with the correct solution. Go ahead. Okay, so I'll just take you right through the whole thing. Y equals mx plus b. We know the slope is -3. I plug in any point x, y. In this case, the y is -4. The x is 2. Didn't make any sloppy mistakes this time. Ooh, yeah. -3 times 2 is -6. Adding the 6 to both sides, b is 2. So that gives me the correct equation, y equals -3x plus 2. But what if I want to use this other way, this point slope way? Well, I would just begin with the slope formula. And in that slope formula, I would leave one of the y's and x's the way they are. Don't substitute in for them because we only have 1 point, first off. And second off, we want a y and an x in the answer for the equation of a line just like this. Okay? So y minus -4 is really y plus 4 over x minus 2 equals the slope. But the slope is -3. So then I cross multiply. -3 is really over 1. When I put that over 1, 1 times y plus 4 is y plus 4. And on the other side, I just get -3 times x minus 2. Now, you might want to rewrite that as y plus 4 equals -3 times parentheses x minus 2. Doesn't make a difference. It's all the same. Okay? Next one. Write the equation of a line passing through the points 2, -3 and -3, 6. This is a little tricky here. Notice this negative was left over here. That's very important. This time I give you the 2 points, and you need to go back and find the slope. So I actually made a mistake. I clicked the button and went one step too far, so there's your slope for you. Now, write the equation of the line in both forms. Go ahead. That's my dog snoring. Oh, she's snoring loud. It's kind of that Catskill gray day out today. Okay, so now we know the slope is -9/5. So that means y equals mx plus b. I know the slope is -9/5. X is -3. Y is equal to 6. Plugging those values in, substituting them in. -9/5 times -3 is 5.4. Subtracting 5.4 from both sides tells me that the b, or the y-intercept, is 0.6. And that tells me y equals -9/5 x plus 0.6. Okay. Now, let me go back here. Let's see you try to do this as we did up here, where you use the point slope method of getting it. Remember, just set up your slope formula, leave one of the variables free. It doesn't matter which point you use. It's either one. It will work out the same. And then you can cross multiply and you'll have your answer. Go ahead. Okay, I assume you did your stop and start there. So -9/5, okay, which is your slope. When I say cross multiply, I got to be careful with that. You're really multiplying both sides by x plus 3. If you cross multiply and put the 5 in front of the y, you're going to get an equivalent equation, but it's not the form that we're looking for. We're looking for that slope to be involved here. So I multiply both sides by x plus 3, and I get -9/5 times x plus 3 equals y minus 6, because on the right side, the x plus 3's cancel each other out. Get abducted by aliens, go die, whatever you want to say. Okay? We're going to work some more on this technique of the point slope form in the coming lesson. So when it comes to equations of a line, there's a standard form, ax plus by equals c. There's the slope intercept form, y equals mx plus b. Horizontal and vertical lines, y equals a constant, x equals a constant. And then we have the point slope form, which we just did. Y minus y1 equals the slope times x minus x1. That's why we left that slope with the 5 in the denominator attached to the m and didn't put it in front of the y. Would it be equivalent? Absolutely. But it's not the proper form. Okay, so let's see you solve these two or write these out. First, write the point slope form and the slope intercept form of the equation of the line with a slope of 6 that passes through the point 2, and then be very careful here, over on the end, -5, 2, -5. Go ahead. Stop and start, of course. Okay, so we know the slope is 6. So, and what we're doing here is we're using the point slope form. So 6 will equal, and I'm using the point 2, -5. So it's y minus a -5, which is y plus 5, over x minus 2. And then it's kind of like cross multiplying, because in this case, there's really a 6 over 1. But what we're actually doing is multiplying both sides by x minus 2 so that we can eliminate the denominator on the right, leaving just the y plus 5. So I get 6 times x minus 2 equals y plus 5. You could switch sides, would be more of a typical order. Y plus 5 equals 6 times x minus 2. That's more of the typical format, but of course, if you see a multiple choice, you're going to see the bottom one, y plus 5 equals 6 times x minus 2. But the one above that would be would also be equivalent, and there's nothing wrong with it at all. Okay, so that's using the point slope formula that works its way through that, okay? I didn't bother writing the y equals mx plus b form. The correct answer to y equals mx plus b would be y equals 6x minus 17, okay? We've done a ton of examples of that. I didn't bother doing it on this one. All right, so now we have the next question, number 2. A line passes through the points -2, -1, and -1, -6. Find the equation of the line in both point slope and slope intercept form. So let's see you do point slope and slope intercept form. Okay. So I'll do some scratch work up here. The first thing I need to do, regardless, is I need to find the slope. So in plugging the coordinates in, I get that the slope works out to be -5, right? -6 minus a -1 over -1 minus a -2. That's -5 over 1. So the slope is -5. -5 equals y plus 1, because we're using this point right here. Okay, y plus 1 over x plus 2, because when you subtract a negative, it becomes addition. Okay, and that, I say cross multiply, but understand, I mean in a limited sense. We're really getting rid of the x plus 2 on both sides. -5 times x plus 2 equals y plus 1, or switching the order, y plus 1 equals -5 times x plus 2. So that's your point slope technique. If I want to do y equals mx plus b technique, that's what I'll do right here. We now know that the slope is -5, so I plug that in. I can use either point. In this case, I'm going to use the point -1, -2, and that gives me -1 equals -5 times -2 plus b. -1 is 10 plus b, subtracting 10 from both sides, and I get b is -11. So y equals -5x minus 11. Okay. Little summary here of what we've learned over the last couple of days. Slopes and parallel lines. As long as the lines are not perfectly vertical, then they have the same slope. If they're perfectly vertical, they have the same slope too. It's just no slope. If two distinct non-vertical lines have the same slope, they're parallel. So in other words, what we're saying is it cuts both ways. If they're parallel, the slopes are the same. And if the slopes are the same, then they're parallel. If you have two distinct vertical lines, they both have undefined slopes, which is the same slope. It's just undefined, all right? And they're also going to be parallel. As far as perpendicular lines, this takes us back to where we some of the early do-its in the video 1 and 2, well, video 2 exactly. Two non-vertical lines are perpendicular, then the product of their slopes is -1, which I prefer to say that the slopes have negative reciprocals of each other, but it's the same exact deal. The slopes are negative reciprocals. If the product is -1, then they're perpendicular. So just like with parallel, it cuts both ways. If they're perpendicular, then the product of the slopes is -1. If the product of the slopes is -1, then they're perpendicular. We could also say if the slopes are negative reciprocals of each other, the lines are perpendicular. And if the lines are perpendicular, then the slopes are negative reciprocals of each other. And last but not least, a horizontal line having a 0 slope is always perpendicular to a vertical line having an undefined slope. That's because undefined means 0 in the denominator. And when you take the reciprocal, you're going to put the 0 in the denominator, which makes undefined. Okay, guys, that's the end of lesson number 20.